In this video, we'll look at dilations where the scale factor is less than 1. Less than 1 means fractional or decimal, such as half, so we can reduce a figure to half its size. If the pre-image is bigger, reducing the figure to half its size is dividing the side measures by 2. We can have 2/3 or 1/4 or 1/5 or 3/5. Any fraction less than 1 is reducing the figure. Let's say I have a triangle. This one, it will be 2/3 its size. And if I have this one, smaller one, is half its size. So to create a smaller triangle, we need to multiply by a scale factor less than 1. It means you're multiplying by a fraction. Fraction means division. If I have this triangle, the small one will be 1/3 its size. In other words, if I divide the size measures by 3, I am getting the smaller image. Or I can say, if this is size 9, I can multiply it by 1/3, which is the same as dividing by 3 to have the smaller image. Let's see how that works on the coordinate plane. So when we have dilations, and in the directions it says right here, draw a dilation using scale factor k half, starting from the origin. That means that the image is going to be half of the original size of this trapezoid ABDC. So I have to start from origin. What that means is the shape on the coordinate plane is going to be towards the origin, reducing its size. So what that means is that every vertex of the trapezoid has to be connected to the origin that determines the placement. That determines the placement of the trapezoid. The trapezoid is going to be somewhere within the rays. So if I completely ignore that side and this side, the trapezoid is going to be smaller and it will be somewhere over here, shrinking it to half its size. Let's see how exactly to use the unit count in order to draw that trapezoid. So starting at the origin, that's where all those segments meet, connecting the origin with the vertices. Then we need to divide each of these distances by 2. There are a few ways to do that. We can divide by 2 and see where the middle is, but exactly by using the count, I have 4 units and going down 1, 2, 3, 4, 5, 6, 7, 8 units. 4 divided by 2 is 2, so I can go 2, and then 8 divided by 4 is 2, which is in the same place right here. So my unit count, the 8 and the 4, from the origin to get to B, I can divide by 2, and that will be 4 by 2. So here's the location of the image B prime. Let's see, to get to A. To get to A from the origin, I have 1, 2, 3, 4, divide by 2, that's 2. 1, 2, 3, 4, divide by 2, it's 2. So that's where is halfway from the origin to A, which is going to be A prime. To get to the vertex C, going from the origin, I have 1, 2, 3, 4. 4 divided by 2 is 2. 1, 2, 3, 4, 5, 6. 6 divided by 2 is 3. So I need to go 2 by 3. 2 by 3. 2 by 3. 2 by 3. That works twice, right? So once I divided it, that unit count should work throughout the distance from the origin to the vertex C. So that is the C prime image. Then to get to D, so I have our B, A prime with C, and I am missing one of the vertices. So this D, I need to figure out where the image is. So how about from the origin, I go up and across. How many units? 1, 2, 3, 4, 5, 6. That would be half 3. 1, 2, 3, 4, 5, 6, half 3. So that means if I go up 3 by 3, I can go again 3 by 3, and that will be image of D prime. Connecting the 4 vertices of the image result to a smaller trapezoid, which is half size of the original one. Let's say AB here was 4 units. The image is 2. 4 divided by 2 is 2. AC was 2 units. Divided by 2, that's 1. DC was 2 units. Divided by 2, that's 1. So the original shape, the size of each side, if you divide by 2, is our image. Let's see the scale factor less than 1, which is a third. So I have a quadrilateral, and I need to draw a dilation using scale factor 1/3. That means that the quadrilateral is going to shrink to a third its size. So it's going to be 3 times smaller, starting at the origin. So that means that every vertex will be connected to the origin. So connect each vertex with the origin, or we can say connect each vertex with 0, 0, which is the origin, and then divide. Fraction means division, so you're going to divide each distance by 3. So divide each distance by 3. Because fraction means division, denominator tells us what to divide by. So we are dividing by 3. Here's our origin. And let's say I have this distance P to the origin. I need to divide it by 3. So I have 3 divided by 3, 1 unit. 1, 2, 3. To get to O, let's say I need to get to O. I have this segment right here, and I need to divide it into 3 equal parts. So I can see from the origin to O, what is the unit count up and across. So I go 1, 2, 3, 4, 5, 6. 6 divided by 3 is 2 by 1. So if I have 1, 2, 3, 3 divided by 3 is 1. So 6 by 3 divided by 3, each count, that would be 2 by 1, 2 by 1, 2 by 1. So if I split the segment into 3 equal parts, each of them is 2 by 1. So 1/3, 2/3, 3/3 to complete the full distance. From the origin to N, I have 6 units across. 6 divided by 3 is 2. So to divide from the origin, the distance to N, we need 2 units. Each segment, 1/3, 2/3, 3/3. And then to get to M, we need to see what the ratio is, and then down and across, and then divide it into 3 equal parts. So here I go down 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 divided by 3 is 3. 1, 2, 3. 3 divided by 3 is 1. So I can go 3 by 1, 3 by 1, 3 by 1. That divides the distance from the origin to m into 3 equal parts. From the origin, again, from the origin, we go 1/3, that's one distance, 2/3, that's 2 out of 3 parts, and then 3/3 is the complete distance. Our image has to be 1/3 the original size, so that means from the origin we take 1/3, that will be m prime. From the origin 1/3, it's 1 out of 3 parts, o prime. To n 1/3, again 1, 2, 3, so 1/3 n prime. And to p 1/3, that'll be p prime. So 1/3 of the original size is the quadrilateral M and O P with primes, which is 1/3 of the size of the original shape. It's 3 times smaller. Another way to check is the side measures. So if from P to M I have 2 by 3, from P to M I can go 2 by 3, 2 by 3, 2 by 3, 3 times. So the size of PM was divided by 3 to get the image. Same goes with MN and MN. I have 3 by 1, so I can go 3 by 1 to check to make sure it fits 3 times throughout, and that is the long MN original divided by 3, the same. And then ON has 1 and 2, so 2 by 1 count, 2 by 1, 2 by 1, 2 by 1 fits in 3 times. And from P to O I have 2 by 2, so 2 by 2 going 1, 2, 3 times. So that works all the way throughout. The actual sides of the figure will be parallel, so the corresponding sides will be parallel, and that's another way to check as well. And the unit count. The unit count is the best bet. Let's see one more example when we have 2/3. So I have a triangle and I need to draw FGH by a factor of 2/3. So I need to dilate triangle FGH by a factor of 2/3. 2/3 is less than 1, so that means that it is going to be a smaller triangle. But now I have to go from point 2, 2. So we need to start with placing point 2, 2 on the coordinate plane. So here's the dilation center. It is not the origin this time. It is 2, 2 on the coordinate plane. Scale factor being 2/3 will be connecting each vertex with 2, 2, and then divide each distance by 3 to start with. So the denominator 3 tells us that we need to divide each distance by 3, but then we'll take 2/3 out of it. So in other words, in the previous example we made it to be 1/3 image of the original size. This time we're going to take 2/3, so it's going to be not 1/3, it will be 2 parts out of 3. So we're going to start with the same procedure. We will connect the center of dilation to each vertex, and then we'll see what the unit count is from the vertex to the center of dilation and divide it by 3. So here we go. From F to the center of dilation, 1, 2, 3, 4, 5, 6. 6 divided by 3 is 2. 1, 2, 3, 4, 5, 6. So that will be 2 by 2 count. 6 divided by 3 is 2. 2 by 2, 2 by 2 gives me a segment divided into 3 equal parts. Okay? So first we are going to just divide each of those distances by 3. Now we have the unit count here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 divided by 3 is 4. 1, 2, 3, 4, 5, 6. 6 divided by 3 is 2. So I can go 4 by 2. I am on the line. And I go 4 by 2. I am on the line. And then I go again 4 by 2. And that is simplifying the unit count into 3 equal parts. And they're all evenly spaced. So 2, 4, 2, 4, 2, 4, up 2 across 4 is the same as 6 by 12. And then the last vertex from the point of dilation or from the center of dilation is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 divided by 3, 4. So I can use 4 units to divide my distance from the center of dilation to H into 3 equal parts. Now, I have 1/3, 2/3, 3/3 to complete the distance. So each distance being divided by 3, we go from the center of dilation and take 2/3. So not 1/3, 2/3. So 2/3 is 1, 2, 2/3 of the full distance from the center of dilation. 1, 2, that will be F prime. For G, 1, 2, G prime. For H, 1, 2, H prime. And then connecting the vertices of the image, we have the similar triangle, which is 2/3 of the original size. To check, I can use the side measures, and I have FG prime, which is the image, and FG, which is the original. So I'm going to check if the ratio works of the image to the original. And that will be 6. If you simplify for 6, that is 2/3. That works. So to check if your scale factor is used correctly, you can use the side measures and set them up in the ratio of your image to the original shape. And once you simplify, that scale factor has to be the same as what's given in the